Hello everyone. Today we will going to see some practice questions from the chapter Physical and Chemical Equilibrium, and this is our part 1. So let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slide. We will going to see some practice questions from question number 1st to question number 8. Let's start with the question number 1. In a chemical reaction, the rate constant for the backward reaction is 7.5 into 10 to the power minus 4. And the equilibrium constant is 1.5. The rate constant for the forward reaction is, so we have given the rate constant for backward reaction, we have given the equilibrium constant for the reaction, we have to find out the rate constant for forward reaction. Options are 5 into 10 to the power minus 4, 2 into 10 to the power minus 3, 1.125 into 10 to the power minus 3, or 9 into 10 to the power minus 4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C, that is 1.125 into 10 to the power minus 3. So let's see how. So we know the relation between the equilibrium constant and backward reaction and forward reaction constants. This is given by this. So on putting the values, we have K value as 1.5. Kf value as Kf we will put because we have to find out the forward reaction rate constant. And Kb we have given as 7.5 into 10 to the power minus 4. So we have Kf is equals to 1.125 into 10 to the power minus 3. Hence, option C will be the correct answer. Okay, let's move to question number 2. 56 gram of nitrogen and 6 gram of hydrogen were kept at 400 degrees Celsius in 1 liter vessel. The equilibrium mixture contained 27.54 gram of NH3. The approximate value of Kc for the above reaction in liters square per mole square is. Options are 0.128, 0.118, 0.148 or 0.008. So we have to find out the value for Kc. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. So we have given 56 gram of N2. We can find out the moles for this, which is 56 divided by 28 molecular mass of nitrogen, and it is coming out as 2 moles of nitrogen. Similarly, for 6 gram of H2, the moles of H2 will be 3 moles, and 27.54 gram NH3 will have 1.62 moles of NH3. Now, at equilibrium, the nitrogen molecule will be equal to the equilibrium mixture which contain NH3 moles. So the NH3 moles divided by the N2 moles which is present initially, which is 2. So it will be 0.81. And at equilibrium, H2 moles will be the total moles or final moles of ammonia at equilibrium divided by 3, which is the moles of hydrogen. So it is equals to 0.54. Now we have our reaction, that is N2 plus 3H2 will give you 2NH3. Initial moles for the N2 are 2, for H2 are 3, and for NH3 is 0. But at equilibrium, we have N2 is equals to 2 minus the N2 molecule present at equilibrium, that is 0.81. And for 3H2, it will be 3 minus 0.54. And for 2NH3, we have given that At equilibrium, the mixture contained 27.54 gram of NH3 and we have converted it to the moles 1.62. So at equilibrium, NH3 will be 1.62 moles. So moles of N2 at equilibrium should be like 2 minus 0.81 should be equals to 1.19 moles. And moles of H2 at equilibrium should be equal to 3 minus 0.54, which is 2.46 moles. And moles of NH3 at equilibrium, we have given 1.62 moles. So we have our number of moles for each of the molecules at the equilibrium. So the rate constant will become equal to the moles or concentration of the product. So as you can see this reaction, we have product as NH3 to the whole power 2 because 2 is the stoichiometric coefficient divided by the reactant's concentration. So 1.19 into 2.46. 2.46 is for H2. So H2 to the H2 concentration to the power 3 because 3 is the stoichiometric coefficient for H2 molecule. Hence the equilibrium constant Kc for this reaction is coming out as 0.148, and thus our option C is the correct answer. Okay, so this is the whole explanation, and this is revolving around the initial moles and equilibrium moles of these reactions, right, of the molecules present in this reaction. And through this we can find out the equilibrium constant. Okay, let's move to question number 3. The concentration of CO2 which will be in equilibrium with 2.5 into 10 to the power minus 2 mole liter inverse of carbon monoxide at 100 degrees Celsius. For the reaction, FeO plus CO will give you Fe plus CO2. The Kc is given as 5.0 and will be. So we have given the concentration of we have given in the question that the concentration of CO2 which will be in equilibrium with this mole liter inverse of CO. That means this concentration of CO at 100 degrees Celsius for the reaction this. So we have given the reaction, we have given the concentration of CO at equilibrium. We have to find out the CO2 concentration at equilibrium and Kc is given for the reaction. So options are 0.5 into 10 to the power minus 1 mole liter inverse, 1.25 into 10 to the power minus 1 mole liter inverse, 2 into 10 to the power minus 2 mole liter inverse, or none of these. So you have 10 seconds to solve this question. After that, we will see that what will be the answer. Okay, so the correct answer is option B. So we know that for any reaction, the equilibrium constant is given by the concentration of product in the gaseous state divided by the concentration of reactants in the gaseous state. So in the product side, we have in the gaseous state CO2 divided by the concentration of CO, which is in the reactant side in the gaseous state. And we have given the Kc for this reaction, that is 5. So 5 will be equal to CO2 concentration divided by the Cu concentration, which is given already. CO2 concentration from this equation by solving is coming out as 1.25 into 10 to the power minus 1 mole liter inverse. And thus the option B is the correct answer. Okay, so let's move to next question, question number 4. 1.1 moles of A are mixed with 2 moles of B and the mixture is kept in a 1 liter flask till the equilibrium A plus 2B will give you 2C plus D is reached. At equilibrium, 0.2 mole of carbon is formed. The equilibrium 0.2 mole of C is formed. The equilibrium constant of our reaction is. So we have to find out the equilibrium constant for this equilibrium reaction. Options are 0.0002, 0.004, 0.001, 0.003. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer for this is C option. So we have given this equation A plus 2B will give you 2C plus D. So let's suppose that initial moles for A is A, 2B is B, 2C will be 0 and D will be also 0. Now at equilibrium, the moles will be, for A it will be A minus X, for 2B it will be B minus 2X, for 2C it will be 2X, and for D it will be X. So X is the amount of moles or amount of ions which is, utilizing in the reaction from the reactants to the product side. So we have given that the value we supposed as A is equals to 1.1, B is equals to 2.2, and 2X, that is the value of 2C at equilibrium, is equals to 0.2. It is given already in the question that at equilibrium 0.2 mole of C is formed. So C is forming as 2C. So the 2X will be equal to 0.2. So from this equation we have X equals to 0.1. Now we know the relation of or equation of equilibrium constant. So it will be the product reactants divided by the reactant, the product concentration divided by the reactant concentration. Now product we have 2C and D, so 2X divided by the 1 liter, because they are the moles, they are in moles, but we have to take the concentration, so divide by 1 liter. And because we have a 1 liter mixture in a flask, and 2X is the number of moles for the 2C, it will be for whole square because it is 2C. 2 is the stoichiometric coefficient, and for D it will be X upon 1 liter divided by the reactants, that is A and 2B. So for A it is A minus X divided by 1 liter, and for 2B it is B minus 2X, the number of moles divided by the volume, and its whole power 2, because 2 is the stoichiometric coefficient at B, with B. So Kc, on solving this, we have 4x cube divided by A minus X into B minus 2X ka whole square. And on putting the X values, because X we have given okay, so we have find out the X value from this equation, that X is equals to 0.1. So on putting the X value as 0.1 and on putting the A and B values given in the question, we have Kc, or the equilibrium constant for the reaction, is equals to 0.001, right? Thus the C option is the correct answer. Okay, let's move to question number 5th. In aqueous solution, the ionization constants for carbonic acid are K1, which is 4.2 into 10 to the power minus 7, and K2, which is 4.8 into 10 to the power minus 11. Now we have to select the correct statement for a saturated 0.034 molar solution of carbonic acid. So we have given the ionization constants for carbonic acid, K1 and K2. We have to find out the correct statement for a saturated 0.034 molar solution of carbonic acid. So statements and options are: the concentration of CO3 minus is 0.034 molar. The concentration of CO3 minus is greater than that of HCO3 minus. The concentration of H positive and HCO3 negative are approximately equal. The concentration of H positive is double that of CO3 minus. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. So we have H2CO3 will give you H positive plus HCO3 negative. And for this, the ionization constant is K1, which is 4.2 into 10 to the power minus 7, given in the question. Now the K2 second ionization constant for the reaction HCO3 minus will give you H plus, and CO3 minus is 4.8 into 10 to the power minus 11. Now as we can see that the K2 is very, very less than the K1, right? So all major part of H positive, total H positive, is equivalent to the H positive from first reaction or from first ionization constant, right? So from equilibrium, the H positive from the first reaction is equivalent to the HCO3 negative concentration, it will be equivalent to the total H positive concentration, right? Hence, our option C statement is the correct answer. Okay, let's move to question number 6. The standard Gibbs energy change at 300 Kelvin for the reaction 2A will give you B plus C is 2494.2 joule. At a given time, the composition of reaction mixture is A is equals to half, B is equals to 2, and C is equals to half. So they are the concentrations of A, B, and C respectively. The reaction proceeds in the, we have to select the correct one from these options. So R value is given and E value is given. So options are forward direction because Q is greater than Kc, reverse direction because Q is greater than Kc, forward direction because Q is less than Kc, or reverse direction because Q is less than Kc. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. We have given the del G naught value, which is 2494.2 joule, and we have given a reaction 2A will give you B plus C. For this reaction, the quotient will be equals to B concentration into C concentration divided by the square of B concentration. On putting the values, we have Q is equals to 4, and therefore we know that del G is equals to del G naught plus RT ln Q. We know this equation, right? So this is the equation of Gibbs free energy. Del G equals to del G naught plus RT ln Q. We have Q, we have del N G naught. We just put it in this and solve it. We have a value which is positive value. So we also know that del G is equals to RT ln Q by Kc. And we can observe that if del G is positive, that means Q is greater than Kc, right? If this is a positive term, that means this numerator is greater than the denominator. Therefore, the reaction is spontaneous and it is in reverse direction. Okay. So these are the conditions we use from the delta G or Gibbs free energy change concept to solve this question. And we have the correct option, which is option B. Okay, let's move to next question. Question number 7. For the reaction, 2NO2 will give you 2NO plus O2. Kc is given at 184 degrees Celsius and R is given. So when Kp and Kc are compared at 184 degrees Celsius, it is found that what is found? The options are whether Kp is greater than, less than, or equal to Kc depends upon the total gas pressure. Kp is equals to Kc, Kp is less than Kc, or Kp is greater than Kc. You have 10 seconds to visualize the answer to solve the question. Then we see what will be the answer. Okay, so the correct answer is option D. So we have given this equation 2NO2 will give you 2NO plus O2, and Kc for this reaction is also given at 184 degrees Celsius. We can say 457 Kelvin. R value is also given. So we know that Kp is equals to Kc times RT to the power del Ng. In this reaction, we have the reactants and the products all are in gaseous states. Del Ng will be equals to 2 plus 1, 3 minus 2. So 3 minus 2 is 1. So del Ng is 1. Now Kp will become equals to KcRT. So we put we put the values, Kc value, R value, and T value in Kelvin. And we have Kp, which is this, which is of course greater than the Kc value, which is this given in the question. Thus, we can say that the Kp is greater than the Kc. And hence our D option is the correct answer. Okay, let's move to next question. Question number 8. For the reaction, carbon monoxide plus chlorine will give you COCl2. And for this reaction, we have to find out the Kp by Kc. So options are 1 by RT, under root RT, or 1. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see the answer. The correct answer is option A. So we have Kp is equals to Kc R to the power del RT to the power del Ng. We know this equation, right? And we have this reaction. So del Ng for this reaction is 1 minus 2, which is 1 minus 1. So Kp will become equals to Kc R to the power RT to the power minus 1. That means Kp divided by Kc equals to RT to the power minus 1, which is equals to 1 upon RT. So we can say that Kp by Kc equals to 1 upon RT. And thus, our option A is the correct answer. Thank you.